A $3,000 propeller decision is quietly robbing boats of 7 to 11 miles per hour, and most owners don't realize it until they're 2 seasons in, watching every other boat pass them at the sandbar. This isn't about horsepower, it's not about hull design, it's about a single component that Chinese outboard manufacturers spec differently than you think, and the physics don't care about your budget. By the end of this, you'll know exactly which propellers are bleeding your speed, why dealers stay quiet about it, and what to check before you ever turn a key. Here's what everyone repeats. Chinese outboards are cheap, so you save money up front and accept slightly lower performance. That's the trade-off. You've heard it 100 times. But that story is incomplete, and the incomplete part costs you more than the engine discount ever saved. The real issue isn't build quality or material strength, it's propeller geometry. And the gap between what these engines ship with and what they actually need is wider than the gap between a Yamaha and a Mercury in raw reliability. Let me show you the mechanism most people miss. When a Chinese outboard leaves the factory, it's matched with a propeller that prioritizes one thing: passing the emissions and noise tests required for export certification. That propeller is not optimized for your hull, your load, or your typical cruise speed. It's optimized for a static test bench in a compliance lab. The pitch is conservative, the blade area is large, the cup is minimal, and the result is an engine that lugs under load, over-revs when empty, and never hits the RPM range where it makes peak power. You're not getting 70% of a Japanese outboard speed. You're getting 70% of your own engine's potential, because the wrong propeller is acting like a governor. Now here's the twist. The factories know this. They engineer these engines with decent power curves, reasonable fuel maps, and legitimate materials in the lower units. But they also know that most buyers will never swap the propeller, never check wide-open throttle RPM, and never realize the engine is choking. So they ship it with the safe prop, the one that won't grenade a gearbox if someone runs it full throttle in 3-foot seas with a cooler full of ice and 4 adults on board. That's not dishonest, that's liability management, but it leaves speed on the table, and if you don't know how to pick it up, you'll spend years thinking your engine is just slow. Let me give you a comparison that makes this clear. Imagine buying a pickup truck and the manufacturer installs highway tires rated for 65 miles per hour, even though the engine and transmission can handle 85. You drive it for 2 years, never passing anyone on the interstate, assuming that's just how the truck performs. Then someone tells you to swap the tires for a different load range, and suddenly you're cruising at 75, getting better fuel economy, and the engine isn't screaming at 4,000 RPM anymore. That's what's happening with these outboards. The propeller is the tire, and most of you are driving on the wrong set. Here's where it gets expensive. A lot of owners figure this out after they've already bought the engine, installed it, and run it for a season. By then, they've told themselves the performance is acceptable, or they've convinced themselves that Chinese outboards are just slower, or they've started shopping for a repower with a Japanese brand. All of those responses cost money. The first costs you time and frustration every time you're late to the fishing spot. The second costs you the resale value of an engine that could have been dialed in. The third cost you $8,000 to $12,000 for a new powerhead when a $400 propeller would have solved it. Don't click off. This is where people get trapped, because once you understand the propeller math, you realize the factory setup is designed to protect the engine, not maximize your experience. And the dealers selling these engines don't bring it up, because explaining propeller selection requires 20 minutes of education, and most buyers just want to know if the engine will start and if it's cheaper than a Yamaha. So the propeller conversation never happens. You take delivery, you bolt it on, you run it, and you never know what you're missing until someone with the same hull and a different prop smokes you on plane. Let me break down the real mechanism here, the thing that controls whether your engine performs or suffocates. Every outboard has a recommended wide-open throttle RPM range, usually printed in the owner's manual. For most Chinese four-strokes in the 60 to 150 horsepower range, that's 5,500 to 6,200 RPM. If your engine is revving below that range at wide-open throttle, the propeller has too much pitch or too much diameter, and you're losing speed because the engine can't reach its power band. If it's revving above that range, the propeller has too little pitch, and you're over-revving, burning extra fuel and still not getting the speed you should because the blades are cavitating or slipping. The factory propeller is almost always on the low side of that range, sometimes 4,800 to 5,200 RPM, because that keeps the engine safe under worst-case loading, but it also keeps you slow. Here's a real-world case. A guy in Louisiana bought a Chinese-built 90-horsepower outboard for his 21-foot bay boat. The engine came with a 13-pitch, 3-blade aluminum propeller. First time out, the boat planed fine, ran quiet, burned reasonable fuel, but top speed was 32 miles per hour, and he knew other boats with similar hulls and similar weight were hitting 40 to 42. He checked the manual. Wide-open throttle spec was 5,500 to 6,200 RPM. He borrowed a tachometer, did a wide-open run, and found the engine was spinning at 5,100, under-propped. He swapped to a 15-pitch stainless prop with slightly less blade area and more cup. Next run, the engine hit 5,800 RPM, and the boat ran 39 miles per hour. Same engine, same hull, same fuel, 7 miles per hour faster, because the propeller finally let the engine breathe. Now, watch what happens when you ignore this. You run the factory prop for 2 seasons, you get used to the speed or lack of it. You start thinking the engine is underpowered, so you baby it. Never run it hard, maybe even add a jack plate trying to squeeze out another mile per hour. None of that works, because the problem is internal to the propeller engine match. Eventually, you decide to sell the boat or repower. And now you're taking a loss on an engine that was never broken, it just needed a different prop. That's a $2,000 to $4,000 mistake, depending on how fast you panic and how much you spend trying to fix a problem you never correctly diagnosed. Here's the thing dealers won't tell you, because it complicates the sale and opens up a support conversation they're not staffed to handle. Propeller selection is not a one-size-fits-all spec, it's a process. You need to know your hull style, your typical load, your cruise speed preference, and your engine's torque curve. Most Chinese outboard dealers don't have that data, or they have it but don't explain it, because they're moving volume and they assume you'll either figure it out or not care. Japanese outboard dealers have the same issue, but they get away with it because Yamaha and Suzuki ship engines with propellers that are closer to optimized for the average use case. Chinese factories don't have that decades of market feedback, so their default props are more conservative, and the gap between factory and optimal is bigger. Let me show you the hidden incentive structure. The factory wants to minimize warranty claims. A propeller that's slightly under-pitched means the engine won't over-rev and blow a piston if someone runs it hard in shallow water. It means the gearbox won't see excessive shock loads if someone hits a log at full throttle. It means the engine passes emissions testing, ships cleanly, and doesn't come back with expensive failures in the first year. All of that is rational from the manufacturer's perspective, but it's not rational from your perspective, because you're the one stuck with a slow boat, wondering why you saved $5,000 on the engine, but can't keep up with your buddy who spent $12,000 on a Yamaha. Here's the part that makes people angry. Most of these Chinese outboards, when properly propped, can run within 3 to 5 miles per hour of a comparable Japanese engine. Not the same, but close enough that the price difference becomes worth it for a lot of buyers. But that only works if you're willing to do the propeller homework, test different pitches, measure RPM under load, and possibly spend $300 to $500 on a better prop. If you don't do that, you're running a 70% version of the engine you bought, and the cost of that gap, over 5 years, is more than the cost of the right propeller. You lose time on the water, you burn more fuel because the engine is lugging, you lose resale value because the next buyer test drives your boat and thinks the engine is weak, and you lose confidence in the entire Chinese outboard category, which means you'll probably never buy one again, even though the problem was solvable. But the real problem is this. Most buyers don't know how to measure wide-open throttle RPM, don't have access to a tachometer, and don't know what pitch or cup or blade area even mean. so they rely on the dealer to set them up correctly. And the dealer, in most cases, just bolts on whatever propeller the engine shipped with, splashes the boat, confirms it starts and shifts, and sends you on your way. There's no tuning process. There's no performance validation. There's just a handshake and a hope that you're satisfied. And that's where the system fails you. Because the dealer's incentive is to move inventory, not to maximize your top speed. Now let me walk you through the specific things you need to understand about propellers, because this is the knowledge gap that's costing you speed and money. I'm going to number these, and I want you to treat this like a diagnostic checklist. If you're buying a Chinese outboard, or if you already own one and you're frustrated with performance, these are the variables that matter. 1. Pitch is the theoretical distance a propeller would move forward in one full rotation if there were no slippage. A higher pitch number means more distance per revolution, which means higher top speed, but more load on the engine. A lower pitch means less distance, which means better acceleration, but lower top speed. The factory propeller on most Chinese outboards is conservatively low-pitched, sometimes 12 to 13 inches, when the hull and engine combo could handle 15 to 17. That's where your missing speed is hiding. 2. The only way to know if your propeller pitch is correct is to measure wide-open throttle RPM with a tachometer or a GPS-based diagnostic tool. If you're below the manufacturer's recommended range, you need more pitch. If you're above it, you need less. This is not a guess. This is physics. And if your dealer didn't do this test before you took delivery, you're running on factory assumptions, not real-world data. Here's the twist. Most GPS chart plotters and fish finders don't show engine RPM unless you've wired in a tachometer signal, or you're running a digital engine with NMEA integration. A lot of older or budget boats don't have that, so you're stuck either borrowing a portable tachometer, paying a marine mechanic to do a sea trial, or just guessing based on how the engine sounds. And guessing is where people lose speed, because they assume the engine is doing what it should, when in reality it's 400 RPM short of the power band. 3. Blade area is the total surface area of the propeller blades. More blade area means better grip in rough water or with heavy loads, but it also means more drag and more load on the engine. Less blade area means less drag, easier spinning, and higher RPM, but it can cause cavitation if the hull or load creates a lot of turbulence. Chinese outboards typically ship with high blade area props because that's the safest spec for unknown use cases. But if you're running a light hull on calm water, you're dragging extra blade surface for no reason, and it's costing you 2 to 4 miles per hour. 4. Cup is a small curve on the trailing edge of each propeller blade. More cup increases bite, reduces ventilation, and can allow you to run a slightly higher pitch without losing RPM. Less cup means the propeller is more likely to ventilate in turns or in rough water. Factory props on Chinese outboards usually have minimal cup because it's cheaper to manufacture and easier to match across different engine sizes. But if you upgrade to a propeller with more cup, you can often increase pitch by 1 or 2 inches and still stay in the RPM range, which translates directly to more speed. 5. Material matters, but not the way people think. Aluminum props are cheaper, softer, and easier to repair if you hit something. Stainless steel props are more expensive, stiffer, and hold their shape better under load, which means less flex and better performance at higher speeds. A stainless prop can give you 1 to 3 miles per hour over an identical aluminum prop, just because it doesn't flex. But here's the catch. If you're running a Chinese outboard and you hit a rock or a stump, the aluminum prop will bend and absorb some of the shock. A stainless prop won't bend, so the shock goes straight into the gearbox, and now you're looking at a lower unit rebuild. That's a trade-off, and it depends on where you boat and how careful you are. Now, here's where people get stuck. They read all this, they understand the theory, and then they go to a marine parts website and they see 40 different propellers that might fit their engine, all with different pitch, diameter, blade count, and price. And they don't know which one to pick because the product descriptions are vague and the reviews are from people running different holes. So they either buy the cheapest one, or they buy the most expensive one, or they give up and stick with the factory prop. All three of those choices are wrong because you can't pick a propeller from a catalog without knowing your engine's current RPM under load. 6. The correct process is this. Run your boat at wide open throttle with your typical load, meaning the fuel, gear, and people you usually carry. Measure RPM. Compare it to the manufacturer's spec range. If you're low, go up 1 to 2 inches of pitch. If you're high, go down 1 inch. If you're in range but the boat feels sluggish or you want more top speed, consider switching to a stainless prop with more cup and the same or slightly higher pitch. Then test again. That's how you dial it in. It's not magic, it's iteration. 7. Here's what most buyers don't realize. The factory propeller is not matched to your boat. It's matched to a generic test hole that the factory uses for certification. Your boat might be lighter, heavier, narrower, or wider. Your engine height might be different. Your load distribution might be different. All of those variables change the optimal propeller spec, and the factory can't account for them because they don't know what hole you're mounting the engine on. So the factory prop is a starting point, not a final answer. And if you treat it like a final answer, you're leaving speed and efficiency on the table. 8. The cost of getting this wrong is cumulative. Every hour you run a mismatched propeller, you're either over-revving and burning extra fuel, or you're under-revving and lugging the engine, which increases wear on the pistons, bearings, and gearbox. Over 500 hours of use, that's measurable. You're spending more fuel, you're shortening engine life, and you're not getting the performance you paid for. A $400 propeller upgrade, if it puts you in the correct RPM range, pays for itself in fuel savings and reduced wear within 2 to 3 seasons. Don't click off because this next part is the trap most people walk into without seeing it. Once you've run a Chinese outboard for a full season with the wrong propeller, you start to normalize the performance. You tell yourself, this is just how it is. Chinese engines are slower. And that belief becomes a self-fulfilling prophecy because you stop looking for solutions, you stop asking questions, you accept the compromise. And when it comes time to sell the boat or trade up, that acceptance costs you because the next buyer test drives your rig, feels the sluggish hole shot and the low top speed, and offers you $2,000 less than you were hoping for. That's the hidden cost of never dialing in the prop. It's not just performance, it's resale value. 9. Here's the thing about 3-blade versus 4-blade propellers. A 3-blade prop generally gives you higher top speed because there's less drag. A 4-blade prop gives you better hole shot, better grip in rough water, and a smoother ride because the load is distributed across more blades. Factory Chinese outboards almost always ship with 3-blade props because they're cheaper and they hit the top speed numbers that look good on the spec sheet. But if you're running a heavy hull, or if you're in and out of no-wake zones a lot, or if you run in choppy water, a 4-blade prop might actually give you better real-world performance even if the GPS top speed drops by 1 or 2 miles per hour. The question is what matters more to you, the number on the GPS or the way the boat feels under load? 10. Ventilation and cavitation are not the same thing, and understanding the difference will save you from buying the wrong propeller. Ventilation is when air from the surface gets sucked down to the propeller blades, usually in a hard turn or when the engine is trimmed too high. The blades lose grip, RPM spikes, and the boat slows down. Cavitation is when the propeller blades are spinning so fast that they create vapor bubbles on the blade's surface, which collapse and erode the metal. Ventilation is a setup problem. Cavitation is a propeller design or pitch problem. If you're getting ventilation, you need more cup, or you need to lower the engine. If you're getting cavitation, you need a propeller with more blade area or less pitch. Factory props on Chinese outboards are usually designed to avoid both, which means they're conservative, which means they're slow. 11. Here's the math that dealers don't explain. Every inch of pitch at the same RPM translates to roughly 1 to 1.5 miles per hour of speed gain, depending on the hull and gearbox ratio. If your engine is running at 5,200 RPM with a 13-pitch prop, and you swap to a 15-pitch prop and the RPM drops to 5,100, you've added 2 inches of pitch but lost 100 RPM. The net result is usually a gain of 1 to 2 miles per hour, assuming you're not so low on RPM that you've fallen out of the power band. But if swapping to 15 pitch drops you to 4,800 RPM, you've gone too far, and you'll actually lose speed because the engine can't make power that low. This is why testing matters. You can't just bolt on a higher pitch and hope. You have to measure the result. 12. Let me tell you about a buyer in Texas who learned this the expensive way. He bought a Chinese 115 horsepower outboard for his center console. Factory prop was a 13-pitch aluminum 3-blade. The boat topped out at 34 miles per hour, and he thought that was fine until he joined a fishing forum and saw other owners with the same hull hitting 41. He called the dealer, asked if they'd swap the prop, and the dealer told him the factory prop was correct for his engine. He didn't push back. He ran it for another year. Then he sold the boat, and the buyer noticed the low speed during the sea trial and negotiated $3,500 off the asking price. That $3,500 was the cost of never questioning the factory setup. A $400 propeller would have saved him $3,000 in resale value, but he didn't know to ask, and the dealer didn't volunteer the information. 13. Here's what happens when you try to use a propeller selector tool online. You enter your engine model, your hull length, your typical load, and the tool spits out 3 or 4 propeller options. But those tools are built on generic algorithms, and they don't account for engine height, transom angle, hull dead rise, or the actual RPM your engine is currently spinning. So the recommendation might be close, or it might be completely wrong. The only reliable way to pick a propeller is to start with real data from your current setup, then make one change at a time and test the result. That's slower, it's more work, but it's the only way to avoid spending money on a propeller that doesn't solve your problem. 14. If you're buying a Chinese outboard and the dealer offers to set you up with the right prop, ask them how they're determining that. If they say, "We'll use what the factory recommends," that's not an answer. If they say, "We'll test it on the water and adjust if needed," that's better, but make sure they actually do it. If they say, "Most people run a 15 pitch and it works fine," that's a guess, and guesses cost you speed. The dealer should be willing to do a sea trial, measure RPM, compare it to the spec sheet, and swap props if necessary. If they're not willing to do that, they're not setting you up for success. They're setting you up to accept whatever the factory shipped. 15. Here's the final thing most people never consider. Propeller technology has improved significantly in the last 10 years, especially in the mid-range price bracket. You can now buy propellers with advanced blade geometries, tuned cup profiles, and computer-modeled hydrodynamics for $500 to $700, and those props can outperform factory props that cost half as much. But Chinese outboard factories are still using propeller designs from 10 to 15 years ago because retooling molds is expensive and the market doesn't demand it. So the factory prop on your Chinese engine might be equivalent to a mid-2000s Yamaha prop, which means you're leaving modern performance on the table. Upgrading to a current generation propeller, even from a third-party manufacturer, can give you gains that feel like adding 10 horsepower just because the blade design is more efficient. 16. The trap is this. You buy a Chinese outboard because it's $6,000 instead of $14,000. You save $8,000. Then you run it for 3 years with the wrong propeller, burning an extra gallon per hour because the engine is lugging, losing 10 hours per season because you're slower getting to your spots, and accepting a lower resale value because the next buyer thinks the engine is weak. Over 3 years, that extra fuel cost is maybe $400. The lost time is harder to quantify, but it's real, and the resale hit is $1,500 to $3,000. Add it up, and you've given back half the money you saved just because you didn't spend $400 in 2 hours dialing in the propeller. That's the math nobody talks about. 17. Here's what you need to ask before you buy. Does this engine come with a propeller matched to my hull, or is it the factory default? If it's the default, what's the pitch, and what RPM range should I expect at wide open throttle? Will you test it on the water after installation and adjust if necessary? If the answer to that last question is no, you're on your own, and you need to plan for a propeller swap within the first season. 18. If you already own a Chinese outboard and you're reading this, frustrated because your boat is slower than it should be, here's the move. Borrow or rent a portable tachometer. Load the boat with your typical gear. Run it at wide open throttle in calm water. Note the RPM. Compare it to the manufacturer's recommended range, which should be in your owner's manual or on the manufacturer's website. If you're low, buy a propeller with 1 to 2 inches more pitch. If you're high, buy one with 1 inch less. If you're in range but you want more speed, consider a stainless prop with more cup. Test it, measure again, adjust as needed. That's the process, and it works, but you have to be willing to iterate. 19. The thing that makes people hesitate is the fear of spending $400 on the wrong propeller. That's valid, but here's the counter-argument. If you pick a propeller based on measured RPM data, and you move 1 to 2 inches at a time, your risk is low. And even if you pick wrong, you can resell the propeller for $250 to $300, so your net loss is $100 to $150. Compare that to the cost of running the wrong prop for 3 years, which we just calculated at $2,000 to $4,000 in fuel and resale value. The downside of testing is small. The downside of not testing is huge. 20. Here's the final knife. Cheap engines don't ruin people. Fragile systems do. A Chinese outboard with the right propeller, maintained correctly, will give you 5 to 7 years of solid service and performance that's 85 to 90% of a Japanese engine. But a Chinese outboard with the wrong propeller is a liability because it underperforms, frustrates you, costs you money in ways you don't immediately see, and convinces you that the entire category is garbage. The engine didn't fail you, the system around it did, because nobody taught you how to set it up correctly, and the people selling it didn't have the incentive or the knowledge to do it for you. Now here's the point where most buyers realize they're stuck. You've already bought the engine, you've already installed it, you've already told yourself it's fine, or good enough, or acceptable for what you paid. And now you're learning that you could have had 7 more miles per hour, better fuel economy, and a smoother power band if someone had just shown you this process before you splashed the boat. That's the moment where people get angry, not at the engine, but at the lack of information. And that anger is justified because this isn't hidden knowledge, it's basic propeller theory. But the people who should have explained it to you didn't, because it wasn't convenient or profitable or simple enough to fit into a 10-minute sales pitch. Here's the trap you need to avoid going forward. Don't let the sunk cost of buying the wrong setup stop you from fixing it now. The engine is already installed. The money is already spent. The question is whether you're going to spend another 3 years running it wrong, or whether you're going to spend one afternoon and $400 dialing it in. The second option pays for itself, and it turns a frustrating engine into a tool that actually works for you. Let me give you the action plan, because everything up to this point has been diagnosis and explanation. Now you need steps. If you're buying a Chinese outboard, do these 7 checks. 1. Ask the dealer what propeller the engine ships with, and confirm it's not just the factory default. 2. Ask them to run a sea trial and measure wide-open throttle RPM before you take delivery. 3. Confirm that RPM falls within the manufacturer's recommended range. 4. If it doesn't, ask them to swap the propeller before you take the boat home. 5. Get a copy of the owner's manual and check the recommended RPM range yourself so you're not relying on the dealer's word. 6. Plan for a propeller upgrade within the first season, even if the dealer says the factory prop is fine, because dealers optimize for convenience, not your top speed. 7. Keep the factory propeller in your garage, because if you ever hit something and damage the upgraded prop, you'll want a backup. If you already own a Chinese outboard, do these 5 moves. 1. Measure your current wide-open throttle RPM using a tachometer or a diagnostic tool. 2. Compare it to the manufacturer's spec range. 3. If you're low, buy a propeller with 1 to 2 inches more pitch in the same material and blade count. 4. If you're high, buy a propeller with 1 inch less pitch. 5. Test the new propeller, measure again, and adjust as needed. This isn't complicated, it's just iterative. Here's the closing. A $400 propeller decision is the difference between a Chinese outboard that frustrates you and a Chinese outboard that performs. The engine you bought has the power, the lower unit has the strength, the fuel system has the efficiency. But if the propeller is wrong, none of that matters, because the propeller is the interface between the engine and the water. And if that interface is mismatched, you're driving a boat that's slower, thirstier, and worth less than it should be. The factories won't fix this. The dealers won't fix this. You have to fix it. And now you know how.